Okay. Oh, I forgot to record. Okay. So, uh, yeah. So in this case, the target was a box, and this box, um, it seemed a little bit big. So I think this, like, there's some size limitations to the target. See, this one was a little bit big, but yeah, yeah. All right. Let's get started. All right. Let's go. Okay. Wait. Yeah. All right. So in the Middle Ages, um, so now that you know how this event works, let's get into how um like how this device was created. Or yeah. Um, the name of the device that you guys will be making in this event is the trebuchet. This device was created as a battle machine in the Middle Ages that threw large stones and projectiles at enemies and castle walls. This trebuchet was especially preferred by the militaries because of its great force and great accuracy. Now, in this picture, the trebuchet is fairly big, and obviously because they're using it to hit like castles and stuff that are very far away. But in this event, we're gonna make a very miniature version of this. And by miniature, I mean like very small, like I think within like a little bit more than a foot. So yeah, it's very small. All right. All right, now let's over the rules. Okay, so there's some rules on the device dimensions. So like I said before, it's very small. So you're going to have your device has to fit within a 65 centimeter rule. I mean a cube where so yeah, it has to be like less than 65 centimeters in any dimension. This is very hard because you need to like optimize your device in order for you to be able to launch a ball very far. Now we'll get into that stuff later. All right, so there's some rules on setups, and this may seem a little bit complicated, but it's really not that complicated. So we start off with a 1 meter by 1 meter square, and um this is where you're gonna put in your device, and beyond this 1 meter by 1 meter square, you're gonna have to be 75 centimeters apart. And in this picture, it looks a little bit bigger than 75 centimeters, but yeah, this is 75 centimeters. And you have to launch the ball, like release your trebuchet, like 75, like beyond this 75 centimeter line, where this is so that um like you don't contribute some external forces into the ball, and like and so that you can't really cheat, right? So yeah, they do that kind of stuff in this event. All right. Um, okay. All right. The next is the energy rule. Um, Now this rule is just also so that you don't really cheat. But yeah, the launch force must be entirely supplied by the gravitational potential energy from the supervisor, provided following counterweights. The device without the counterweight and projectile must not contribute energy to the launch. So what this basically means is that your counterweights um, should not um, the the counterweight should be the only force, or the the counterweight should be the only like force that's uh making the ball launch. So you cannot uh like for example, you cannot have a spring which um which will launch the ball further. Yeah, so you cannot have that. You can only have like have the ball launch by the counterweight that falls like here. So yeah, there's a way that they prove it where I'm not gonna get into that. All right. Now we have rules on the counterweights and the projectiles. So there's two different weights that you're going to use. So usually people create two different like rods, like these rods, to um like accommodate to the two different counterweights. So there's one heavier weight, which is like greater than 1,500 grams. It depends on like what they set it to be like on in each year. So the rules change, right? Yeah. So there's also a lightweight. So use a longer weight beam for the heavyweight and a shorter beam for the lightweight. And you're going to use two different projectiles. I'm pretty sure it's the same for each year, I think. So yeah, there's one heavier counterweight. Wait, yeah, there's one heavier projectile, the tennis ball, which is approximately this many grams, and racquetball. I'm not sure what if you know what a racquetball looks like, but it's like a bouncy ball, and it's a lot lighter. Yeah. Okay. So here's some examples of trebuchet designs, and these are a little bit complicated, but yeah, this is the most used. So it's very basic. There's a base and then a beam where it says arm here. Yeah. And a pivot where like you have to make this beam be able to spin, and a trigger. You just like release this, and then this counterweight will fall down, and then this will go up and it'll launch the ball. So yeah, you're gonna have to have some kind of release, and like you release it like a rope or something, and this just keeps this tight, right? See here it says pin, where they just put a pin through it. Yeah. All right. Um. All right. Let's go through the physics of the trebuchet. Um. All right. So a trebuchet is a device with great power and great accuracy. The most basic concept you would need to know in this competition is the energy rule, and this is the energy rule is on the rule book, where like I just showed you guys, and if your device does not follow it, you'll probably be disqualified. And it's really important because uh you need to follow this in order, because like if you don't follow this rule, then you're pretty much cheating. So basically the potential energy of the counterweight, like this the counterweight is this thing, which falls, and yeah, the potential energy of the counterweight has to be converted into the kinetic energy of the payload, which is this like ball, right? And the kinetic energy ultimately supplies the payload with energy, which launches it into the air. In more scientific terms, the energy of the following counterweight launches it. Wait, no, the energy of this falling counterweight launches the ball and the projectile using a mechanical advantage to achieve a high launch speed. All right. Here are some factors to keep in mind while designing a trebuchet. How long should the beam be? Where should the pivot point be on the beam? How high the ground should and the no, how high off the ground the pivot should be? How heavy should the counterweight and the payload be? Again, the payload is just like the ball. All right. now let's go over some more physics, which are extremely important when understanding why everything happens scientifically. Okay, so this projectile motion and conservation of energy. I'm not sure if you guys have learned the kinematics equations, but that's going to help you in hand calculations. And conservation of energy is mostly like applied in the energy rule thing, where potential energy of the counterweight is being converted into the kinetic energy, which is like the energy where the ball is moving. If you guys are sending me chats, I can't really see it. Send it to, I don't know if Nelson's still in the call. But yeah, I'll answer them later. All right. So conservation of energy. So yeah, that it's just basically like energy does not disappear. So the energy of the counterweight falling gets converted into the energy of the ball moving. So yeah, the energy does not disappear, and the total energy of the system, it remains constant. All right. Okay. So here you'll need to use projectile equations to derive the position of the payload as a function of time, where this wouldn't, okay, so yeah, this is not going to be really covered here because you haven't really learned trigonometry yet. So you can't really hand calculate without like knowing trigonometry, but there's like simulations online which makes things a lot easier. So yeah. Just know like conservation of energy, which is very important. Uh-huh. Yeah. Okay. All right, next. All right. So now let's go over some tips that'll definitely help when building your trebuchet and to create great accuracy and great distance. Okay. So the first tip is that the beam on the counterweight side, which is like this side, no, this side, right? Yeah, yeah, this side, no, this side, yeah. So it has to make a 45-degree angle from the vertical. So the vertical is just like this, 90 degrees from the ground. And yeah, so this is optimal where the ball is being released here when it's exactly like around 45 degrees from the vertical. All right. This is just a suggestion because this isn't really used all the time, but you can make it like 3 to 2 or whatever. But essentially, um, you want to make the length, the shorter side to the longer side as like 1:4 ratio. Um, where the longer side of the beam should be roughly 4 times more than I mean longer than the shorter side. But when I did it back then, I think it was like 3 to 2, so it doesn't really matter. Just as long as this side is longer, I guess. Yeah. All right. Okay. Next tip. So essentially this is the string that is connected to the longer beam, where once this longer beam reaches around 45 degrees, then this string will launch the ball, right? So yeah, essentially this tip is just saying that the length of the string and the length of this longer beam should be around equal, which to be honest, it doesn't really matter that much, but you need to adjust it so that it's around that, like the same. And another part of this is that the mass of the counterweight should be greater than mass of the payload, which is kind of obvious because you're not gonna have a ball that's over 1 kilogram. All right. Okay, so here's a sample test data log. You might not know what this really means, but the Science Olympiad is going to make you create these kind of graphs of your test data, and really this it's just some logs of you testing it at home or like at a park or whatever, but you must create a a graph or like some data of your test cases, um like when you did it by yourself, and this is part of your grade, I'm pretty sure, or like your scoring. And I don't think it's worth that much, but you still have to do it. Yeah. All right, Kahoots. That's all. We're going to do a Kahoot. I'm going to send a link in the chat. Give me 1 second.
I just joined. What are we doing?
Well, we're pretty much done, so
Trebuchet.
yeah. All right. I'm gonna send a link soon. Give me 1 second.
I don't think you're supposed to send a link. I think there's supposed to be code.
Yeah, but you can. It's faster for you to just click the link. You automatically join. All right. Hold on. I send it to all.
What's the pin?
Hold on. Give me 1 second. All right. You know what? I'm just gonna share the pin. All right. Everybody join now. Oops.
Player limit reached.
Oh.
Yeah. Player net limit reached.
You could try editing these settings.
The
Wait, I
player
think I have to
limit-
use a different account. Hold on. Give me 1 second. Hold on.
do that for a
All right.
time.
I'm sorry. I'm gonna have to switch accounts. I used the wrong account. I'm sorry.
It's fine.
It's okay. Okay. Respect.
All right. Hold on. Give me 1 second.
Jason, what do you need? I'm back.
No, I need to switch accounts. Like I used the wrong account. He's
I can get it pulled up really quickly if you want me to just do it.
oh yeah, just do it.
Yeah, give me a sec. Shared with me, right? Are we
Wait, you
doing?
got your appendix removed?
That's yesterday stuff. Jason, what event is this? Storm the castle.
Storm the castle, yeah.
Okay. Give me a sec. I'm starting the game.
Why do you call yourself Bright Future for All?
I'm using the organization account. Okay, everyone join. PogChamp.
For some reason, when I get into Kahoot, it just says nothing. Just says I'm in 0th place.
What?
Load?
Try refreshing it.
Maybe it's your internet.
My internet. For some reason, disconnected.
Just type in the real code.
I'll type in the code, but it's on the screen, so you guys should be able to see it.
I still can't get into the Kahoot. What the heck?
How do I send the link?
Just kahoot.it and then
Click on
you
the game
type in
pin.
thing.
I
Wait, click on the
I
game.
Click
typed
on
on
it.
Shock! It works. Link is in chat, boys. Okay. I have been given a public service announcement. If it says you're in 0th place, you are using the wrong link. Perhaps you are still on yesterday's links.
When I enter the game pin, it says the game pin is not identified.
Probably typed in the wrong thing.
No, you can't. Yeah, like, did you put in a space? Like, there's no. I mean, it has a space on it, but you can't.
You don't like type in the space.
Oh.
Can you wait for me? For some reason, my Kahoot just didn't load. It just loaded.
Yeah, take your time.
16.
My screen just went blank.
I don't know. Then.
Okay, I joined.
My screen is still blank.
Jason, tell me when to start.
All right. Wait, how many people are inside?
Oh, well, I have no idea what happened, but I think I started anyways.
I think they can still join even when you start it.
Yeah.
The
I'm
game pin is
Kansas.
in the chat.
Would I do Kahoot? What the?
All right. Okay. I guess everybody got it right. That means everybody was listening. Okay. Next one.
Well, I didn't listen because I missed it, but I still got
All
it.
right. That's great, Kobe. I'll give you guys plenty of time for this one. Take your time.
You got partial credit if you chose one of the answers correctly.
Yeah.
I don't.
Yes, but the thing is, if you choose 2, if you don't get both of them correct, you get 0 points.
Yeah,
Wait,
so
can
you
you
don't.
can you tell us how many answers there are?
There's two. It literally
Okay.
says select two, dog.
Oh.
All right, we're pretty mixed here. Okay. Yeah. So, yeah. So this is the energy rule, right?
I can't believe I got that right. I basically just guessed.
So okay. if you guys put launch force is supplied by the kinetic energy of the arm. Well, the thing is, okay, this is kind of a bad problem, but the kinetic energy is like the moving. It's like you can think about it as the energy of moving, right? And the thing that's moving is the ball, right? So the object that you're looking at here is the ball, and you're thinking of a system that does not contain the arm. It's just the ball and yeah, the counterweight, and the counterweight is falling, right? So it's losing the system is losing gravitational potential energy while the ball is gaining kinetic energy because it's getting faster, right? And the arm isn't moving that fast, right? So yeah, so that's why that's wrong. All right, so what is correct? The launch force is only supplied by the gravitational potential energy from the counterweight. So yeah, it's gravitational potential energy where the higher it is, the higher the gravitational potential energy. And when the counterweight falls, the gravitational potential energy decreases, and then the kinetic energy of the ball increases. So yeah, that's what the energy rule is. All right, it looks like most of you guys got this right. All right, okay. This is just vocabulary. If you put trebuchet, I'm disappointed in you. All right, good job. Okay, come on now, sling. All right. The projectile is what you're launching, right? All right, good job.
I'm on the leaderboard. I'm in 5th place.
I'm on the podium.
That's great. All right, next.
I'm 69 points behind Lucas.
All right, I feel like I've seen this like a million. I've said this like a million times.
69 points.
I'd be really sorry for somebody who pressed dumbbell
Yeah, me too.
or frame.
All right, I guess
Like
everybody
got
straight.
that correct.
Yeah, I know. Yeah.
Show the leaderboard.
All right, show them the leaderboard. All right, good job, Anna. Okay, this one is just making sure you're paying attention or not. It doesn't really matter, but yeah.
I forgot this one, so I had to just guess.
Ooh. You're a naughty boy.
Wait, 2 answers were correct?
Wait,
Like
what?
11.
Oh, yeah.
Two?
It doesn't really matter. All right, go to this. Ooh, this one's tricky. Think outside of the box. All right, I was just bluffing you. All right. next.
Jason, that was evil.
That
That's
wasn't evil.
Ooh, think outside of the box.
What's with you in boxes?
Um,
I agree.
Wait, why does red have? Why does
Wrong.
it say 65.0? What's the 0.0 for?
It's just there.
oh, oh,
Oh, I think, wasn't it 76 meters?
yeah, it's 65 centimeters.
Oh,
I
wait.
think okay, well, you don't really need to memorize this part because I'm
I'm
pretty sure the
so
rules
sad.
change. I'm pretty sure the rules change every year. So this is probably valid like 2 years ago. So yeah.
Well, Rome is 15th place.
Oh, that's great. All right, Andrew next. Good job, Anna.
I'm gonna go with
It literally says infinite kilograms.
All right, if you put true, then you're trolling. Next. You cannot. The Science Olympiad sets a certain mass for you. Okay, you cannot just do whatever you want. All right, next. Again, this doesn't really matter that much when you're creating it by yourself, because you're going to need to do a lot of trial and error. It's just testing it out. But yeah, this is just ideal. Okay. Okay. Next. All right, good job, eggs. Nice. All right, Alex. Good job. You're the winner. You get
Congrats, Alex.
nothing.
I was fifth. Yay.
That's so mean. You just said you get nothing.